In this video for Computer Science 9618 A-Level, we're going to be taking a look at a Paper 3 topic, specifically one that focuses on lexical analysis. Let's go ahead and jump in. So what do we mean when we say lexical analysis? What is it? Well, it's the very first stage of compiling a program. Now, in the lexical analysis stage, white space, the spaces between your words or any blank coding lines that you did not use, any documentation, comments, and any other unnecessary characters, they're going to be removed from your source code, meaning it's not going to be compiled. These comments, this documentation, the white spaces, they're not required by the compiler for you to compile and run your program. The source code needs to be converted to what we call tokens, and this is called tokenization. But what are tokens? Well, the compiler looks for keywords in a table, and these are the reserved words used by the programming language. It creates those tokens. Now, any variables or constants that you create get added to the symbol table because these are part of your programs. It recognizes those and creates tokens for those as well. So let's take a look at what this looks like and go through a Paper 3 test question that could appear on your exam so you can be successful. The compilation process has a number of stages. The first stage is lexical analysis, just like we said earlier. A compiler uses a keyword table and a symbol table. This right here is a keyword table. These are the reserved words that a programming language recognizes, and it says part of the keyword table is shown. Tokens for keywords are shown in hexadecimal. Now you may be saying, how did these tokens come into play? We're going to get in that towards the end of the video. All of the keyword tokens are in the range 00 to 5F. So lexical analysis. Remember, all comments and white space are removed because these are not needed by the compiler. So anytime it encounters some comments, it's going to get rid of it. It's just going to ignore it. It is not needed by the program. Now, all keywords are identified and looked up in a keyword table, just like the one we looked at earlier. Keywords do include things like the equal sign, math operations, the assignment arrow, any symbol that is in the keyword table, the program recognizes. Now, in this pseudocode example, they are all the words that are all uppercase or recognized symbols. So it starts at the very beginning. We see the start doesn't know what that is. We encounter the arrow. The computer knows what that is. It recognizes it in the keyword table. It sees the number 1. It knows what the number 1 is, but it's not a key word. We're going to talk about where that goes in just a few minutes. Then it recognizes input, says, I know what that is. Doesn't know what number is just yet. Remember, all comments are ignored, so it skips down to this 4. Recognizes that keyword. Doesn't recognize counter. Does recognize the arrow because that appears in the keyword table. Start has no idea what that is just yet. What about 2, TO? That's recognized in the keyword table. 12, it knows it's a number, but it doesn't know where it goes quite yet. So it's not going to create a token for it just yet. What about output? Output, it knows what that is because that is a key word. What about number? Has no idea. What about that asterisk, the multiplication symbol? Recognizes that because that is in the keyword table. Then we have in 4. The computer has recognized all the words in the keyword table. Now what it's going to do, and this happens all at the same time, it doesn't go through looking for keywords first and then things it doesn't know. I'm just showing you that it recognizes the keywords. Words not recognized by the compiler are added to a symbol table. So this is how it knows what goes inside the symbol table. It looks for the words it cannot recognize. Now, these are the variables that you declared and numerical values. These are not going to be found in the keyword table, so they got to go in the symbol table. So we look at start. The computer doesn't know what that is in the keyword table, so it puts it in the symbol table. It does the same thing with the value of 1. Does the same thing with the variable number. Does the same thing for counter, start, the numerical value 12, number, and counter. This is what it looks like as it goes through and does lexical analysis. If it's in the keyword table, it's good to go because those are already predefined. If it's not in the keyword table, everything that I've outlined here in orange, it goes in the symbol table. But what does a symbol table actually look like? Well, this is what a symbol table looks like. When filling out your symbol table, you're going to do it in order. Remember, the compiler starts from the beginning and moves to the end. This means it goes line by line. Start. The computer doesn't know what start is. Puts it into the symbol table. Has a token value of 60 as well as the type. That's a variable. All this is done by the lexer. Then we look for the arrow. The arrow is recognized in the keyword table. Therefore, it doesn't get added to the symbol table. What about the value of 1? The computer recognizes that as a numerical value. It's not in the keyword table. So our symbol is 1. The value is 61. Because remember, these values are starting from 60. Start is at 60, so we move to the next one, 61. That's why 1 has the value of 61. What about the type? What type is it? 1 will always be 1. That value of 1 never changes. Therefore, it's going to be constant. We look for the next one, input. That's recognized by the keyword table. Number. The computer says, here's something that is not in the keyword table. We need to add that to our symbol table. So it adds number. What value does it have? Well, we start at 60. That's taken. 61. That's taken. 62 is available. What about number? Is it always going to be the same value? Not at all. If the user's inputting a number, they can input any number. So we say it is a variable. Then we ignore the comments, remember? We look for 4. Well, remember, 4 is a key word. So now we take a look at counter. The computer says, I don't see counter in the keyword table. We have to add it to the symbol table. So it adds counter. What about value? What's its value? Well, 60, 61, and 62 are already taken. So we move to the next one, 63. What about counter? Could it change? Is it always going to be the same value? Not always. It could change. So we say it is a variable. We do the same thing and we're looking for the next one that we need. And the next one we need is the number 12. That is the symbol. What value does it have? Well, 60, 61, 62, and 63 are already taken. So now we put it in 64. What about 12? What will that equal? Well, it'll always be 12. That value never changes. So we say it's a constant. What about the rest of it? What about output? That's in the keyword. What about number? We've already defined number. Asterisk, that's in the keyword table. Counter, we've already defined counter. And what about in4? That's in the keyword table. So everything has been defined in this short pseudocode example they have given us. And now we arrive to this part of the question. The output from the lexical analysis stage is stored in the following table. Each cell stores 1 byte of the output. Complete the output from the lexical analysis stage. Use the keyword table. So we want to use our keyword table. And your answer to part A. So there we go. We're going to go through this pseudocode and we're going to go ahead and fill out this table. So we start at the beginning. Start. Where do I find start? What is the token value? That is 60. That's how they got 60. What's next? The arrow. Where's the arrow? Right over here. What's the token? 01. What's the next one? 1. What is the value of 1? That has the value of 61. I move to the next line. Input. I see input has the value of 5, 1. Then we have number. What is number? What is the token value? That's going to be 62. What about these comments? Remember, that's ignored by the compiler, so I'm just going to skip right over those comments. Then we have the keyword 4. I know that's in the keyword table. I look right over here, and I see it has a value of 4e. The next one, counter. Right over here, what is its token value? That's going to be 63. What about this arrow? That's next. That is a keyword. That has a token value of 0, 1. Then we have start. Well, I know start is a symbol because it's not a reserved word. I see start has a value of 60. Then I recognize the keyword TO. I look in the keyword table that has a value of 50. Then I do 12. 12 has a value of 64. 4. Then I move to the next line, output. That is in the reserved or keyword table. So I look for output. That has a value of 5, 2. I look for number, not a keyword, not in the keyword reserved table, but inside the symbol table. I look for number. That has a token value of 62. I look for the asterisk. That is recognized by the compiler. I see right over here, it has a token value of 0, 2. Now I'm looking for counter. Counter has a token value of 63. The last one I'm looking for is end4, and that has a token value of 5, 3. That is the lexical analysis stage, and that is part of compiling a program, specifically the very first stage. If you guys found this video helpful, please take a moment to give it a thumbs up and subscribe to help the channel grow, and we'll see you guys in the next programming video.